Reasoning models think in long chains, and one wrong fact early poisons everything after it. Ask who directed Slap Hershey's French. The model hallucinates Jim Abrahams, then builds a birth date on top of that wrong name, then ships a wrong answer. The error was always tiny. The chain made it fatal. A 2026 paper called Checkrlm says the fix is not better retrieval and not checking after the fact. It is checking during the chain before the error cascades. Two existing fixes both lose. Direct reasoning trusts its own memory, so the first hallucination propagates unchecked. Post-reasoning check revises the final answer after the full chain is done, but it cannot repair the corrupted reasoning that was already built on the error. Late correction patches the surface, not the foundation. Checkrlm intervenes mid-chain at paragraph granularity with token-level fixes, so the model continues inference from a corrected unit along a correct path. The method has two stages running inside the reasoning loop. Stage 1 is claim recognition. Each reasoning paragraph is scanned for explicit factual claims relevant to the question. Stage 2 is localized correction. Every claim triggers an atomic retrieval, top 3 docs, the results are deduplicated, and a correction model rewrites only the broken tokens, leaving the reasoning structure intact. If the paragraph is already correct, it passes through unchanged. One model, trained with DPO on 5,300 paired samples, does both recognition and correction. The headline. On 5 multi-hop and short-form benchmarks, averaged across 10 cells, Q2Q32B with direct reasoning scores 21.8, Vanilla RAG lifts it to 31.6. Search01 reaches 41.5. Checkrlm hits 45.4. On 2 wiki multi-hop, it pushes exact match from 28 to 62%. The win is consistent across 4 reasoners and 4 checkers, not a single model artifact. The falsifiable evidence that timing is the lever, not retrieval volume. Same model, same checker, same docs. Post-reasoning check versus in-reasoning check on hot pot QA. With the smaller 14B checker, in-reasoning wins by 14.9 points F1. Switch to the 70B checker and the gain halves to 7.5. A stronger checker narrows the gap because even late checking gets better. The in-reasoning advantage is loudest, exactly where errors cascade most, multi-hop, not single-hop where it falls to near zero. Here is the picture. A single wrong premise cascades down the chain like falling dominoes, every step built on the last mistake. Intercept it early and the chain stays standing, each step resting on a corrected fact. That is the whole bet. Minimal, token-level correction at the paragraph where the error is born, instead of a heavy rewrite at the end. The chain holds because nothing corrupts the foundation, the efficiency story on 2 wiki multi-hop. Search01 burns 2008 tokens for 71.4 F1. Checkrlm uses 1,364 tokens, 32% fewer, and scores 73.4 higher. The DPO data that trains the checker is 5,311 samples, split between claim recognition, 2,351, and coherence correction, 2,960. Joint training beats either subset alone. 2 honest caveats. First, the headline numbers use a 70 billion checker sitting alongside the reasoner, and the token and time figures count only the reasoner, so real deployed cost is higher. Checker size is also non-monotonic. The 32B checker sometimes loses to the 14B. Second, the DPO gain is in-domain. Training data comes from 2 wiki multi-hop, so the plus 5.7 there shrinks to plus 1.6 on hotpot QA and plus 0.9 on simple QA. The win is real, but it is not uniform. Checkrlm reframes the error accumulation problem as a timing problem. Intervene mid-chain at paragraph granularity with token-level corrections grounded in retrieved docs, and the model continues from a correct path instead of compounding a wrong one. The payoff, 45.4 average across 5 benchmarks, beating Search01 with 32% fewer tokens. The lever is when you check, not whether. The paper is Checkrlm. Subscribe for the next breakdown.